How would you put a telescope in circle that is greater than the rocket that is going to send off? It is simply even conceivable envisioning that is simple. All that exists in space, or at least in our planetary group, is now there to the extent that we know it all in. Space is very old, so the possibility of something spick and span showing up there appears to be exceptionally impossible anyway. The inverse is valid. The James Webb Space Telescope, by taking inconceivably exact photos of the universe, has caused very much a sensation overall. The magnificence of science is that it invites new data instead of dismissing it. In spite of the warm gathering to new data, some of what the telescope is seeing is as yet confounding and confusing. What have researchers noticed from the James Webb Space Telescope that has them puzzled? What secrets about the dawn of mankind, as far as we might be concerned, has the telescope opened up until this point? We should find out. As of late, NASA, the European Space Organization, and the Canadian Space Office collaborated to give cosmologists around the world an exceptional gift, an opportunity to brief look into the past, at the making of the universe and the edge of time itself. The James Webb Telescope, hailed as the chief observatory of the following 10 years, remains as one of the best logical accomplishments within recent memory. It opened this powerful window into creation not as a philosophical hypothesis, magical time machine, or imaginative representation, however, as a substantial instrument. On December 25, 21, this enormous infrared telescope, more generally known as Webb, was sent off into circle, determined to catch pictures of the obscure and unwinding the secrets of our secret universe. The state-of-the-art infrared location hardware furnished on Webb improves the novel point of view of the universe that Hubble has given mankind, uncovering the concealed universe to our eyes from its vantage point in low Earth circle. Hubble has caught various, until recently never seen, pictures of distant districts and notable times of our universe, investigating the history and advancement of cosmic system stars. Also, cloud, it has portrayed the attributes of dark openings, exoplanets, and the sped-up extension of our universe. This earth-shattering work procured the Nobel Physical Science Prize in 2011. Webb addresses the following stage in our aggregate experience of finding the universe's insider facts and looking for life past Earth. Hubble's pictures have characterized current cosmology, opening our eyes to what lies past and starting our existential interest. As NASA puts it, we want to see farther and more profound. Webb can peer back to the start of time, while Hubble can go similarly as 500 million years after the enormous detonation. How is this conceivable? The latest space telescope flaunts a few benefits over early emanations. Its size is the first remarkable component. JWST has a 6.5 m mirror comprised of 18 gold-plated hexagonal parts. This behemoth can catch light from protests multiple times quicker than the 24-met focal point of the Hubble Space Telescope, since it can accumulate more than 6 times as much light anyway. The valid game share is JWST aversion to infrared light. The space telescope can identify frequencies between 0.6 to 28.5 micron, spreading over the mid-infrared to the red finish of the noticeable range. While most of Hubble's responsiveness shines on noticeable light, its optics are custom-fitted to catch radiation from 0.9 micrometers in the bright to 2.5 micron in the close to infrared. Stargazers can notice universes that framed less than a billion years after the huge explosion. By using the infrared range, these far-off objects transmit apparent and bright light. However, due to the development of the universe, this radiation is presently discharged at longer infrared frequencies. The best way to notice these youthful systems near Earth is through infrared perception. This, moreover, applies to recently shaped stars. Baby suns are encircled by dust which disperses apparent light, darkening our view, yet permitting infrared energy to go through. Infrared radiation is imperceptible to people. The shades of pictures caught by JWST vary from what the natural eye would see to reenact how the eye sees. Researchers frequently map longer infrared frequencies to the red finish of the apparent range and more limited frequencies towards the blue anyway. Incidentally, this example is changed to feature explicit subtleties more. Really, JWST fills in as an generally useful observatory, notwithstanding its center around far-off cosmic systems and star development. Its solid infrared capacities empower it to observe highlights in nearby planet group protests that ordinary telescopes can't notice, concentrating on cloud belts on gas and ice, monster planets, checking cloud arrangements on Titan, examining Pluto's environment, and testing quite a large number more modest space rocks and trans-Neptunian objects, all through the external sun-powered framework, are only a couple of its initial accomplishments when NASA's twofold space rock redirection test crashed into the space rock moon Liptomorphos. JWST even caught a brief look at the occasion. This permitted NASA to concentrate on the item's capacity to modify the direction of that's what possibly dangerous space rocks could cross Earth's way, regardless of the endeavors of planetary researchers to reveal the hoard insider facts of our sun-oriented framework. More than 5,000 known exoplanets in our cosmic system stay obscure. The vast majority of this extra data lies past the capacities of Earth-based telescopes. Counting Hubble anyway, JWST has currently started to change what is happening. While not explicitly intended for exoplanet revelation, JWST distinguished one around the red small star LHS 417541 light-years from Earth. This planet's breadth is just 1% more modest than Earth's. Nevertheless, it circles its sun in only 2 days and flaunts a temperature barely any 100 degrees hotter than Earth. JWST is most noteworthy. Strength lies in its capacity to study exoplanet environments. By noticing travels with its strong spectrographs, cosmologists can research the substance organization of these universes. Most of mixtures important to exoplanet specialists are tracked down in the infrared locale of the range. JWST remarkable goal has took into account the revelation of different compounds on exoplanets, including water, sulfur dioxide, carbon monoxide, sodium, potassium, and carbon dioxide. The gas and dust-rich heavenly hatcheries known as nebulae are where planets and their host stars grow anyway. Notwithstanding their excellence, these mists cover the fundamental cycles happening inside them from the rest of the perspective. JW's infrared vision has started to uncover these secret environments. For instance, the Falcon Cloud, popular for its mainstays of creation photo taken by Hubble in 1995, was one of JWST introductory targets. While Hubble generally noticed hazy residue, what's more, chilly gas, JWST found a few stars that had proactively risen up out of their natal casings. These youthful stars, noticeable external, the shadowy points of support are recognizable by their diffraction spikes in pictures caught by reflecting telescopes like JWST. These disclosures offer important experiences into the arrangement and development of heavenly bodies, revealing insight into the secrets of our universe in their objective stars form into mature stars. However, JWST has found much more as of late, framed objects called protostars. These protostars are still during the time spent engrossing gas and residue from their environmental factors. Every so often they radiate material planes that strike their thick climate, making them transmit Sirius red shines. The two lower points of support are among the best instances of this. peculiarity these protoi are assessed to be a couple 100,000 years of age, as indicated by cosmologists' star arrangement, happens all through the universe and JWST. Researchers are anxious to explore its different indications past our world. Inside our neighborhood bunch two significant areas are the enormous and little melanic mists, the two generally monstrous satellite cosmic systems of the smooth way. It is critical to grasp these worlds, since they contain about a portion of the amount of metals delivered by gigantic stars as the smooth way. This present circumstance looks like circumstances that one when the universe was just 2 or 3 billion years old and universes were creating stars at a most extreme rate. The cosmic systems framed during this vast early afternoon, including those we see currently, was molded by the blasts during this period. The tarantula cloud situated in the huge melanic cloud is the nearest object in the melanic mists to mirroring these turbulent times. The tarantula cloud, the most noteworthy star framing zone in the quick universe, makes stars at a enraged rate. Roughly 820,000 stars have been indexed by stargazers to date, and the colossal stores of hydrogen and helium the cloud hold ought to be adequate for many thousands more. The splendid star group R136, close to the center of the cloud, contains various stars gauging at least 100 sun-powered masses. The JWST is starting perceptions have uncovered unique detail of the tarantula cloud in the centerpiece of the cloud. A sizable air pocket has been gotten out by the extraordinary radiation and heavenly breezes of the enormous stars in R136, hands down the densest neighbor in areas which probably contain child stars of their own can endure this attack. The tarantula cloud gives space experts with a nearby viewpoint of the circumstances they would experience as they further explore the grandiose late morning perceptions of neighboring peculiarities. Frequently assist researchers with seeing more far-off ones all the more obviously. Similarly, a star arrangement in the melanic mist sheds light on comparative cycles in the far compasses of the universe. Planets in our nearby planet group add to the investigation of exoplanets. Likewise, research on Barry acting universes straightforwardly adds to how we might interpret the wild starting points of the universe. JWST was constructed to concentrate on old systems shaped at the start of the universe straightforwardly, and researchers have been getting a charge out of testing this ability anyway. Adjoining districts can regularly act as analogs for more established, more far-off conditions. A profound field picture of the cosmic system bunch SMAC 723 in the Southern Star grouping volumes was one of JW's most memorable pictures. Furthermore, the first made accessible to the public. This openness, which took 125 hours instead of weeks for Hubble's different profound fields, catches cosmic systems exhaustively. These far-off cosmic systems, even fainter and farther away than what Hubble could recognize, are noticeable in the SMAC as a 723 bunch. The light we get from this bunch is from around 4.6 billion years prior anyway, because of the bunch's colossal mass going about as a gravitational focal point. Systems found further away, counting those present inside a billion long periods of the enormous detonation, are noticeable. The littlest worlds in the field arranged uttermost away don't look like the more created twisting and curved systems nearer to our planet. A critical revelation made utilizing the huge world bunch capable 2744 in form as a gravitational focal point is the perception of two universes scarcely 450 million and 350 million years after the huge explosion. Individually, these worlds show up uncommonly splendid and possible, started to structure scarcely 100 million years after the huge explosion. Scientists are uncertain if these universes comprise of various faint stars. Or, on the other hand, a couple of outstandingly brilliant populace. 3 stars accepted to be the first. Stars in the universe made exclusively out of hydrogen and helium. Another new finding by the James Webb Telescope is the imaging of a gathering of cosmic systems, as it were, 600 million years of age from the very beginning of the universe. While the actual age may not be especially interesting, the conditions encompassing this revelation are progressive. By pointing telescopes towards the universe's starting points, we can witness occasions that happened billions of years prior, when their light, in the long run, contacts us. These colossal cosmic systems, just 600 million years or less from the earliest starting point, represent a challenge to our ongoing getting it of cosmic system development. Their quick development brings up issues about the cycles involved and challenges long-held logical speculations. These revelations feature the essential inspiration driving, sending off the James Webb Telescope to push the limits of our insight and challenge acknowledged logical insights. What more Webb will find remains obscure, yet it's sure to proceed, reshaping how we might interpret the universe through its exact perceptions and profound imaging abilities. The James Webb Telescope is ready to reveal more secrets of the universe and possibly upset our appreciation of the universe's initial ages and universe development processes.